Welcome everybody to the October meeting of the Astronomical Society of Edinburgh. For those joining us on YouTube, it'll be a fairly condensed meeting in that we will cover the sky in October with what Horst will take us through, and we'll talk about what's coming up. And then, unfortunately, for non-members, we're going to have to close YouTube down because we're going to hold our annual general meeting for the first time in a virtual world, but at least we can proceed with it. So, do you want to change the slide, Matt? Okay, we have an agenda.
We're just also sharing, Carl. It was 10 seconds to go.
You can put on.
You might want to mute your mics at the moment, thanks. Okay, so we'll just go through the news and what's happening. Then we'll have, as I said, the sky in October from Horst, and then we'll get on to our AGM. So next slide, please, then, Mark. And first of all, whilst we're saying welcome, we have 4 new members, 2 of which joined today. So if you'd like to unmute, we'd like to welcome Ramsey, Ronald, David and Mark to the Society. Really happy to see you on board, and look forward to some interaction as we get to talk through things and discuss things, both on our regular meetings on the first Friday of the month, and we're hoping to do 2 meetings a week. 2 meetings a month going forward. Also, our imaging and observing group meeting, which you're more than welcome to join in. Okay, next slide, please, Mark. And coming up, talking of imaging and observing group, next Wednesday at 7:30, all members are welcome. It's a much more interesting group these days. There's so much going on, and the quality of the images being produced out of this group continues to improve. It's remarkable. If I compare the output for what was happening a year ago and 2 years ago, it's chalk and cheese. It's a terrific work by everybody there. We're hoping through the good offices of Mark to have a Mars live stream like we did the other night for the moon, and looked at a few other objects. I thought that went down extremely well. Thanks, Mark, and everybody else who contributed. Clearly, it'll be short notice. We'll have to take the opportunities when they arise in terms of the weather, but we will publicise it in the normal way through an email and on Facebook. We're looking to have another talk in October, but until that's confirmed, I won't say any more. But what we have got confirmed are 2 talks in November. We've got Looking for Life on Mars by Professor Andrew Coates, who I think is one of the principal scientific officers for one of the cameras on board. And on the 20th of November, we've got Dr. Rebecca Higgett, who's going to talk about, I think, one of John Piazzi Smythe's companions, Edinburgh to Hawaii, and it's all about John Walter Nichol. You may have come across Rebecca before. She helped organise the John Piazzi Smythe Symposium, and has recently moved from the university, I don't know if it was Kent or Warwick, but moved to the National Museum of Scotland, where she's taken residence. So hopefully we'll see a lot more of Rebecca going forward. Thank you, Mark. So we'll hand over to Horst. If you want to share your slides, Horst. And Horst will take us through the sky in October.
Okay, it always takes me a few seconds to share screen for some reason. And I will also switch to my, if I knew how.
That looks good.
Now. Yes, well, I do not have a lot of bandwidth, so I was going to turn myself into a frozen infrared image. And then my sound and the presentation have more chance of getting through. So you should now see the title slide.
Yes.
The sky in October, there are no prizes for guessing what the main object this month should be to observe. I've dug out an image of Mars here that I took in 2005, but Mark Phillips has already been active last month and taken some, so a nice view to look forward to. And the opposition, of course, being in the middle of the month. And as an autumn opposition, it's a relatively good one. It's reasonably high in the sky, and Mars is quite close to the Earth. Now, as usually, I would start with the planets at dusk in the evening twilight sky, but there aren't any unless you count Saturn and Jupiter. So I'm going straight to the dawn sky in the morning, the eastern horizon here, and in 2-day steps where the planets will appear at dawn. Now our cover here is an interval of 6 weeks from yesterday, and these, as I said, 2-day intervals. So Venus stands quite high in the morning sky, quite bright, of course, as well, and it loses a little bit of height over the month, and moves further to the right. Mercury is currently not visible. It is technically in an evening apparition, but for us this far north, it is not visible during twilight. But it will then pass in front of the sun and pop up in the morning sky near the end of the month on the 29th. And it will, by the 11th of November, it will have reached its highest altitude of 10 degrees. So that is quite a decent apparition. So certainly something to look out for. And of course, you can use Venus as a guide for where to look for Mercury. So with the twilight out of the way, what planets are there at night? So there's Jupiter still, as it gets dark, still more or less in the south, next to Sagittarius. Now this is not a horizon map, this is a sky chart. So you would be looking for possibly for constellations, but the brightest thing is the planet Jupiter over here. It has emerged from opposition in summer, so it has turned back into what is called direct motion, moving from right to the left, as planets usually do, the outer planets. And it is speeding up doing this. So it is catching up with Saturn here on the left. This constellation here is the teapot Sagittarius, which we do not see an awful lot of because it just comes over the horizon in summer and is a bit difficult to observe. But if you can find it, then very good. Over here is Scorpio, Antares, the bright star, bright red star, and there's 3 prominent stars here, but I'm not sure you can still see them in autumn. Same map, other planet, Saturn is over here. It does essentially the same as Jupiter, just 2 weeks later. It has also come out of retrograde motion. It is in direct motion, so also speeding up in a right to left movement. But being further from the sun, it is not moving as fast as Jupiter, so that's why Jupiter is going to catch up and will overtake it in a couple of months' time, I guess. And then, of course, already mentioned, there is Mars. Being in opposition, it is visible in principle all night. It rises when the sun sets, and it sets when the sun rises. And I have drawn here a longer track. These are weekly intervals for Mars. So it came up here and then it turned around and went retrograde in early September. And it is now during the opposition phase, it is the retrograde moving to the right. And round about here, it will be in opposition on the 14th of the month. And then in mid-November, it will have reached this point here where it turns back into direct motion. And I think the track ends in, no, don't quote me on that, I'm not sure. But you can count the weeks if you like. Now I've drawn another planetary opposition loop here, which you cannot resolve. So I'm going to show this part a bit larger. This is the planet Uranus, which does essentially the same thing. It came from the right and then it turned retrograde here in mid-August, and it reaches opposition at the end of the month on the 31st, somewhere around here, and it then moves on and goes back into direct motion in mid-January. And I mentioned this partly because it is so close to Mars. So while you're looking at Mars, you might have a side glance at Uranus. What do the planets look like in the telescope? This is to the same scale, all the planets, well, all the classical 5 planets. Mercury, when it appears on the horizon, you can hardly see it. It's a very thin crescent coming from in front of the sun, and technically quite faint. It's plus 3.3 magnitude. But as it moves higher in the sky gets darker and the crescent gets fuller and it gets brighter, reaching minus 0.6 magnitudes. But it does get smaller because it moves further away in its orbit around the sun. So it diminishes from 10 arc seconds to 7 arc seconds diameter. Venus, you may remember, is the brighter one, higher up in the morning sky, but it does in principle the same thing. It moves further away from the Earth. It gets a bit fainter in the process, and it gets a bit smaller in the process. And the phase gets fuller if you look carefully. And at good times, Venus can be almost as large as Jupiter in the telescope, but by now it is too far away from the sun, from the Earth to be that big. And then the star of the month here, of course, is Mars. Now I've made one little mistake. I've drawn it here in the middle at opposition. But as I learned from Alan Pickup's article this week, it is actually closest and therefore largest a few days earlier than opposition. So at the moment, or on the 1st of October, it is 22 arc seconds in diameter. It will reach 22, but behind the decimal point, it will be a small increase, but then it will get smaller, and by mid November it will be 17 or 18 arc seconds. So yeah, have a look while it is at its largest. I have drawn here an insert Uranus at the same scale, but not at the same brightness scale. I have to say it is not that bright. It's a small disk of 4 arc seconds in diameter, but in a reasonably large telescope, you should be able to see that it's not just a star. Its magnitude is also not brilliant, technically just about naked eye, almost. But with binoculars, you should be it should be easily seen, but you need a comparison chart to know which things are stars and which are Uranus. Jupiter here, usually, and also now the largest planet apparently in the telescope, at 41 arc seconds now, and moving slightly further away and getting smaller to 36 arc seconds. Also getting fainter in the process from minus 2.4 to minus 2.1. And Saturn, I always emphasize this is the planetary disk, getting a bit smaller from 17 to 16 arc seconds. but if you count the rings, then it is almost the same size as Jupiter usually. So this should give you an idea of what you might expect to see in a telescope, although you will probably have a bit worse seeing than Stellarium has. Another thing that I learned from Alan's article is the conjunction of the Moon and Venus on the morning of the 14th. So that's just around the Mars opposition, but this will be only the one morning. On the eastern horizon, there's the Moon and Venus about three or 4 degrees apart. But the Moon is a very thin crescent, and they both stand beneath Leo, the constellation Leo here, Regulus, the bright star, and the body of the lion and the head of the lion. Zooming in a bit, this gives you an impression, given the size of the Moon, how far away Venus is, and it also gives you an impression that it is a very thin lunar crescent of only 10% illuminated. But this means that the Earthshine should be very prominent, and in particular, this being an autumn morning at 5 o'clock in the morning, these stand already 10 degrees above the horizon, and it is still completely dark. This in the morning to do this kind of observation is best in autumn, whereas in the evening it's best in spring. This is a completely different event, a completely different date. This is a lunar occultation where the Moon moves in front of the star. Here is the star as it is about to go behind the Moon. The star is 2.8 magnitudes, which is reasonably bright. So this should be quite easy to observe, especially on the dark limb of the Moon. So this is on the 21st of October. A bit low on the southwest horizon. And you see the lunar crescent. And around a 7:15, the star should disappear here behind the dark limb. And about an hour later, it should reappear here on the bright side, which is a bit more difficult to observe because of the brightness of the Moon. But that is something perhaps also to look out for. That is not, it's not very rare for this sort of thing to happen, but it is also, probably have to wait a couple of years for something this bright to go behind the Moon. Ignore this green spot here. That's just an artifact from the software. So yeah, I would use a telescope to observe the Moon and get a good look, high magnification, to get a good look at the star. So what's next? Stars. The stars at night in the west, looking west. Here's the west point on the horizon. So there's the constellation Bootes setting with the bright star Arcturus, which you can find if you follow the arc of the Big Dipper, or the Plough, or Ursa Major, the Great Bear. Down you get to come to Arcturus. Next to it is a very small but quite recognizable constellation, the Corona Borealis, the Northern Crown. And over here is also another smaller, even more recognizable constellation, Lyra, with the very bright star Vega and a small parallelogram. Vega is one of the 3 stars of the Summer Triangle, which the other 2 are Deneb up here in Cygnus, the Swan, and over here Altair in Aquila, the Eagle. Now, which objects did I want to mention here? Alcomisa, sorry, is a double star in the Big Dipper. Here, where the handle makes the turn. This is a double star which you should be able to split with a naked eye. But if you point a telescope at it, then you will see that the main star is also a relatively close double star. Another double star is Albireo or Albir. I don't know the Anglo-Saxon pronunciations, I'm afraid. Albireo is the second brightest star in Cygnus here, the head of the swan. And as a double star, it is interesting because the two stars are very different color, and this is very easy to see. It's usually difficult to estimate colors of stars, but when two different colors are so close together in the telescope, then it's quite markedly. Epsilon Lyrae is another double star here in Lyra, next to Vega. It is quite close to be split with the naked eye. You need good eyesight. But if you take a sizable telescope to it, then you will see that each of them is a very close double star again. So it's called the double star sometimes. M13 is the most is the best globular cluster to be seen from the northern skies. This is in Hercules, and I always need a second to find Hercules. It's these four stars form the main part of Hercules, and if you take the right side of the four sides and go up 2/3, then here is M13. It's a globular cluster, which means there are about 100,000 stars very close together, so that you cannot resolve them, and they're gravitationally bound. Another two objects, I think they're both in the ASE 24, is M57, the Ring Nebula, is up here in Lyra. And M27 is the Dumbbell Nebula, which is this one here. When you found it, you have come to an M-shaped asterism. But you can, from Albireo, from the head of the swan, if you go to the left, then you should get to the right region. Well, I should mention the timing for these charts is at 9 o'clock at the middle of the month. If you go out 2 weeks earlier, then you have to wait an hour longer for the same stars, and 2 weeks later you have to come out an hour earlier. But by then we're on GMT, so it looks like 2 hours earlier. So looking south, we have still the planets, Jupiter and Saturn down here. There's the Eagle again, Cygnus, the Swan. And then it's a bit of an empty region here. There's a small constellation, Delphinus, which you may be able to recognize. There's 4 stars here and the tail downwards. And here on the left is the constellation of Pegasus, the square of Pegasus. It's in mythology, this is a horse with wings, and this is the neck of the horse and the head of the horse. And if you follow it onwards here, this is the globular cluster M15, which is another one of the ASE 24, and there is another one, M2, a globular cluster down here. So if you found M15, you just go down to M2, about the same length as the sides of Pegasus. And then over here we have Mars, quite high in the southeastern sky. And I have shown Neptune just for completeness. Now, if memory serves me right, this little point here is green and marks where Neptune is. That should probably also be visible with binoculars, but again, you need a star chart to know which of them is not a star but is Neptune. But it is 1 or 2 magnitudes fainter than Uranus, because it is further away from the sun, of course. Other objects I wanted to mention, M11, the Wild Duck cluster, is at the tip of the wing of the Eagle down here. It's an open cluster, which means it's only at most a few hundred stars, and you can resolve them, and they probably drift apart. They are not gravitationally bound, but it's another type of star cluster. And this one is quite rich and interesting to look at. So next, looking to the east, the constellations that are rising in the east, Pegasus still prominent. And once you found the square of Pegasus, if you take the top left, as it were, star of the square, from here starts the chain of stars, the Andromeda constellation. And if halfway you take a turn to the north and find these two stars, then you have arrived at the Andromeda galaxy. Now, this is technically quite bright, visible to the naked eye, but it is very extended. It is not that easy to spot. And if you want to look for it for the first time, a telescope may not be the best choice. Binoculars would be the best, or perhaps otherwise, if you can't find it with the naked eye, try to take a picture and see whether the camera can make more of it. So that is M31, the Andromeda galaxy. M33 is much more difficult to observe. It's even lower surface brightness. It's down here, but it has the imaging group has taken a shine to this one and like to take images of it, because it is actually quite a challenge, or even to take an image. It's called the Triangulum galaxy because these three stars not only form a triangle, it's also called the Triangle constellation. Further to the left, we have the Milky Way here with Cassiopeia, the W constellation. Very easy to recognize. And next down is Perseus here with a wide open cluster or star group. And between the two constellations is the double open cluster, Chi and H Persei. So these are two open clusters about 7,000 or 8,000 light years away. But they are not a physical pair of clusters. They are still 1,000 light years apart. M34 is another object in the ASE 24, an open cluster over here. So between Perseus and Andromeda is M34. And then there are two very easy to spot, open clusters M45, the Pleiades, the Seven Sisters, so called because you can usually see 6 stars in them. And the Hyades is a much wider open cluster here near the bright star Aldebaran, which I believe is not a member of the cluster. Okay, this is the same view to the east, but instead of 9 o'clock, it's 2 hours later at 11 o'clock, and by this time Orion is rising. And Gemini has risen in the northeast. And I've marked here where the radiant of the Orionid meteor shower is, because there is a meteor shower active almost the whole month. Well, the whole month actually, and a bit more until early November. The maximum is on the 22nd, but it is apparently quite spread out. So a couple of days within that should still give you very good rates. The nominal rate is 20 meteors per hour in ideal conditions, which there never are, like the radiant is not directly above us. So, but as meteor showers goes, this is one of the more worth looking for over the year. There are about half a dozen such showers over the year. The BAA handbook says this about them: they are fast meteors, and many have persistent trains, which means the tail shines for a few seconds afterwards. Yeah, flat maximum, several sub-peaks. Good in 2007. Not sure what I do with that information, but very favorable. By that they mean that the moon does not spoil the view, i.e. is either a crescent or not above the horizon at all. One snag though is, even at 11 o'clock, the radiant is just rising. So it's kind of, meteor watch is kind of something for the second half of the night, really. Right, well, that is in fact all I have about the predictions for the month. This is looking back at some of the images that the imaging group have taken over the month. So as I mentioned, the M33, the Triangulum Galaxy here, taken by Nigel Goodman. And he brings out very well also the colors of the foreground stars, but there's also the spiral structure, of course, the bright core, and these spiral arms, they go on longer than you might think. And so I think a lot of data went into this, because I once tried and it took me a lot of frames to get not quite this far. This is the moon taken by Ian Smith, and he was doing his homework for the imaging group there, because he spotted the objects on the moon, Lunar 9 out of the 100 and 15 out of the 100. There's a list of 100 things on the moon to look for. And number 9 is the crater Clavius, which has a sequence of decreasing or increasing size craters inside it. That is 9, number 9. Number 15 is the straight wall, which is up here, the bright line here, which is a step in the terrain on the moon. So on the left, the terrain is lower than on the right, and the sun shining from this side, it shines on the wall to make it bright. It's usually easier to spot in the opposite phase, not just after last quarter, but after first quarter, because then this will be a shadow, which is much easier to spot. This image was taken by Mark Phillips of the, I think it's called the Bubble Nebula. With some of these modern names, I'm not too convinced how well established they are. But it's definitely NGC 7635. So this looks to me like an H2 region, the red light from ionized hydrogen. So the interstellar hydrogen gets ionized, excited, probably by the UV ultraviolet radiation from this star. And as the atoms sort themselves out again, they emit, amongst others, the red spectral line of H alpha. Something similar is happening in this nebula. I'm not too sure about the colors, but this is a very deep and very impressive image that Mike took, Mike McGovern, of the Western Veil Nebula. So this all belongs to the Western Veil Nebula. The Eastern Veil is beyond the margins of the image, to the bottom. And this is a huge bubble of gas expanding into the interstellar medium from a supernova explosion. And this is in Cygnus, just under the wing of the swan. And then finally, there has been some aurora, quite low on the horizon and not terribly bright, I guess. And Fran Goodman took this image from Aber Lady, looking to the north over the Forth, which you can't see here, under the Big Dipper, a green arc of aurora with rays going upwards. And with that, I've come to my end.
Well, thank you, Horst. Perhaps we can show our appreciation. Excellent. Move the slides back. Sorry, Michael. The slides back. Great. Well, thank you very much. And I guess for those viewers on YouTube, that'll be it for tonight. And please join us again for our next meeting. Meanwhile, we'll carry on with our